Okay. Today's topic is introduction to cloud computing concepts, benefits, and so many things we need to learn. I mean, from the basics of cloud computing and what are the things before we are doing cloud computing. Okay. So there is two segment. First, we learn the cloud computing basics, then how we set up all the infrastructure before cloud computing. So you have any idea what is cloud computing in a nutshell?
Cloud is a computer that's somewhere else. So somebody has built a big data center with lots of different types of machines and operating systems. And instead of spending money on your company's site, maintaining your own IT infrastructure, you outsource that. It's like a utility. Like we don't make electricity at our house. We buy electricity from the utility company for an hourly rate or whatever units of electricity we consume. So
Hmm.
same, whatever units of compute and memory you consumed, you buy. But compute is a little more complex than just electricity power units. So you have a lot of optimized choices. Like, do you want memory to be fast? Do you want it to be slow? Or do you want it to be sure? Do you want backups? Do you want to be optimized for different things? Like, do you want to be optimized for compute? Do you want to be optimized for bandwidth, input, output? So accordingly, you will pick a machine configuration that is good for you, and it will be running remotely, but you will have either it's connected through your infrastructure or it is purely in the cloud, means on somebody else's data center infrastructure. So it's using somebody else's data structure infrastructure basically, and uh, paying like a utility bill.
Yes, right, right. So you have the basics or some understanding what is cloud computing and all the things, right?
Yes.
Okay, well, um, okay, then I will start from the traditional way. Okay. Consider this is a office. Okay, and traditionally this is a office. I mean, this is a scenario before the cloud computing and all. So you have the knowledge, right? I mean, how we set up the all infrastructure before on-premise. This is called on-premise or on-prem. Okay, this is an on-prem scenario. Just leave the cloud on all the things. Uh, for example, this is a company. Okay, so this company have different section, right? And I mean, this is some accounting section. This is some other section like management section. So, I mean, consider this is a building and this is the rooms, like, I mean, where they're working. And one
Yes.
more, yeah, same way, this is IT section. Okay, there is a IT infrastructure section there.
Yes.
And some more section. Okay, some other employees are working here like that. Okay, so each sections there is employees, right? So we need to provide the uh, I mean their working station like PCs. So here there is 3 computers there. Same way here, 2 computers. I mean, each department there is some employees considered like that. And here also have different employees there. These are the computers. Okay, and total
Yes.
these much computers are here. And this is the IT infrastructure, or I mean server room. Okay,
Which is the server room, the empty rectangle?
this is this one.
Okay. Yeah.
So here there is so many IT peripherals there. Okay, I mean, here there is a rack. We keep IT infrastructures mostly in racks. You
Right.
heard about racks, right? I mean, like
Yes.
Alamara. Yeah, we keep
It's
all
basically a
the
stack of computers. It's a shelf filled with
uh,
computers.
yes,
On the
computers and other devices also. I mean,
yeah, yeah.
switches, routers, firewalls,
Okay. Yeah.
yeah,
Yeah.
modem. We can keep all the things in the racks. I mean,
Yeah.
yeah. So basically, this is a high level infrastructure. Okay, in a, consider this is a hospital or school, colleges, any small size corporate, or all IT infrastructures are like this. Okay, in on premise.
Yes. Yes.
So yeah, and coming this first we set up all the things. Okay, like set up the LAN actually. Okay, for communicating. For example, this machines. This is mission one consider, and this is 2, 3 like that. Okay, this is like
Yes.
eighth mission or anything like that. So this first
There are 10
mission,
machines.
sorry.
In your diagram, there are 10 machines.
Yes, yeah, and just
3, 2, 5.
yeah, okay. This is the 10th one. Okay, so the first mission needs talk with the 10th mission. Okay,
Right.
these two missions are the same building but different floors or anything like that. Okay, so
Yes.
this machine, okay, this user, this is here is a user, right, who operate, I mean, who manage the system. So this machine needs to access some files or something from this machine. So any idea how this works?
There is a local area network called acronym LAN. The computers will send packets. Each within the LAN, they can distribute the. So the IP address has two parts. One is for the outside world, and one is for the inside local connection. So it's kind of like your mailman will come to your building and drop the mail off, but then inside the house there are different people living, so everybody will get their own mail packet, right? So uh, that way the the data packets are sent on the network, but they have the IP address of the receiving machine and the port. And if the port is configured, there are different protocols like TCP, UDP, and there are different ports on the machines to listen to the packets. If the port is kept open to receive certain protocol, then that machine can talk over that protocol. And from a cybersecurity perspective, they will manage that. I mean, some ports they will keep closed. They will not allow communication on that, so the machine cannot be attacked. But basically, if they are all trusted machines, then they have a way of sending packets to each other, and there is like a Kerberos ticket, and key encryption keys can be. There is a system through which security of the communication can be maintained. That's basically how the machines will talk to each other. And then there's sometimes a lot of packets will go. They're designed to like TCP or UDP will be like different protocols, right? So some protocol will keep sending packets until they're received. Some packets have a lifespan, how long it should stay in the system, so packets don't keep floating around. So it's a lot of things happening behind the scenes. But the simple story is that packets are put on the network, and they have a recipient that they go to, and the recipient will have the decryption for that packet.
Yes, yes. Yeah, that's right actually. So yeah. First thing, these machines are connected to a network, right?
Yes.
It is called. We create a LAN connection between these machines inside this premise. So
Yes.
yeah, I will explain from the scratch. Okay. So just we brought up the machine and set up in here. Then this next section is we put in some operating system like Windows 7 or Windows 8, any operating system in each machine. The next thing is we need to plug up some LAN cable. Okay. Take one LAN cable. Consider this is the LAN cable. Okay. And put it in the LAN port of this machine. And the next hint where we put, any idea?
There will be a router, I think.
Yeah,
Right?
right. Not a router, it's a switch actually.
Switch.
So we set up the switches in the rack actually. Okay.
Okay.
So we put that switch, I mean the port into this switch. Okay. Now this machine can talk with the switch. Okay.
Yeah.
So we do the same thing for each machine, like take a LAN cable and put in the switch. So these two machines can talk, right? If the
Yeah.
IP is same, I mean, most probably when we set up local area network, we need to provide the local IP for each machine, or else we configure the DHCP. There is a service, the dynamic host control protocol. So that DHCP will allocate some IP for this machine. I mean, random IPs. We set up the IPs pool actually. From that pool, and the DHCP will provide the thing, or else we need to provide IPs manually, local IPs. For example, this machine we need to provide an IP. Same way, we need to provide another IP for the next machine, and each IPs are same same network and configuration file. I mean, to consider this is a IP. We providing this local IP. Okay, 192.168.0.1.
Yeah.
So this is a one machine, okay, like 0.1, and this machine will 0.2. This is 0.3. Like that, we providing IP.
Yes.
So we plug it in the switch, okay. So here same way we need to plug it in here. Here also plug it here, and plug it here. Like that similar way we need to.
There are LAN cables, Ethernet cables all over the office, basically, office building.
Yes. There is a
You
connection
have
there.
a plug to put in the LAN.
Yes.
It used to be Ethernet. I think now, what cables do they use? Is it still Ethernet or?
Cats, I think Cat 6 cable like that. There's a cable configuration there. Cat 5, Cat 6. So
Optical fiber cables?
no.
Optical.
No. This is inside the premise actually.
Okay.
From this machine, I mean, from the IT room to the last building or the floor is less than 100 meter or anything like that. We can choose this Cat 6 cable. Okay, no problem.
Cat 6 cable.
Yeah. And coming to optical, it's costly. Then we need to change the switch as per the optical cable. I mean, you can't directly plug it in this side type switch. Okay.
Like the high frequency trading or something where they need the speed is very critical. They will invest in the more expensive.
Yes,
network.
then we can go with the fiber optics cables.
Yeah.
So and one more scenario actually, for consider this IT room and this last room. Okay, this is the last room is too far. Okay, this is too far from this machine, this IT server room. Then we are not going with these machines. We leave all the LAN cable. Okay, let's cutting all the thing. Then we put another switch here. Okay, consider another switch here and plug it all the thing in this switch.
Like an electric sub panel.
No. Then we set up a fiber connection from this switch. Okay, this switch to this switch.
Yeah. No, right now working on an electrical wiring project, and in the building, where the new section of the building is, instead of making all the cables go back to the main junction box, there is another sub panel put there. So a big electric cable comes to feeds the sub panel, and then from the sub panel, all the wires to the new place in the building happens. Kind of similar description for electricity.
You mean power on internet? That's the thing, right?
Yeah, for power. Yeah.
Yes. Sometimes we need to provide some electric power through the through the LAN cable actually. For the
I was just bringing an analogy of how the electrical wires and the similarity for the other switch you put in a distant room, right?
Yes.
Analogy, they do the same. They apply the same logic to electrical wiring on a building.
Okay. So yeah, so this is a high level view. Okay, I mean how the local area network now we can say this is a local area network. Got it? So
Yes.
the next thing is now we just connected this mission, right? So so we need to connect with some application server. Okay, I mean these machines, all the machines need to access some application of this infrastructure, this on-premise application. So I mean we have an application. Okay, for this company there is an application, so the employees are accessing I mean log into the application and they will work. Okay, consider like that the scenario. So what we'll do, we need to buy a server.
The application server.
Yes, no, this is a bare metal server. Then we need to configure the server. I mean, installing the server or OS. Then we need to deploy the application. Okay, the application the users need to access. So inside the server, we need to deploy the application server. So there is no connection. Okay, how the users access the application in area in locally. Now we are just plug it a server and deploy the installing the operating system and configure the application. Everything is done in this server.
I think they.
I mean the
So I
connection.
think computers, everything is there's more behind the scenes than you know, right? So if it's a web-based application, they would be accessing it through the intranet. Or
Actually,
internet.
this is a internet actually. LAN is a, we can call it as intranet.
Intranet, okay.
Yeah.
But their communication protocols are the same. Are they same like internet?
I mean,
Only the
the
packet
connection.
doesn't travel far out. The packets stay inside the building.
I mean, consider this leave the thing. Okay, I mean, the server is not in the rack. Okay, we set up the rack in the same IT infrastructure. This is our server. So we configure and configure the application is done. Okay, how each client machine access the application? That's the question. Any idea?
So does it have to exchange some encryption information, public key, private key, and then
No. I mean, now there is no connection, right? From this machine. This.
Oh, okay,
Yeah.
So this machine, that's the application server, will also have IP address, and the switch will know the IP address, and there'll be like a
Plug it.
DNS server that translates the request to the IP address.
Yeah, I mean that we take a cable, LAN cable, and put it in the switch. The server, and plug it in the switch.
Yeah.
This is the thing I am meaning actually. So all the machines that is connected with the switch can access this server.
Yeah.
Some we need to configure something, some network levels configuration there. The IPs, the ping connection, all the things. Sometimes firewall may make some issues, so we need to disable the things in some PC. After that, we can directly access this machine. So next thing is these machines need to access internet. Okay, this is internet. Okay, we need to access internet. So what will you do? Take a modem connection and keep it in the rack or anywhere in the IT room. Then take a there's out in and out section in the modem. So take a LAN cable from the out section and put it in the switch. Now all the machines can access internet. Got it?
Yes.
Any other application or any other file sharing server there, then do the same thing. This is another server. Okay, this is another server. We keep in the server room, and this is for the entirely for file sharing or file accessing these machines. So we keep all the files in this machine. All the users are share their daily working file or anything in this file machine. Okay, so do the same thing, like take a cable and plug it in the switch.
That machine might be optimized for input output, the file server.
Yes.
Application one might be optimized for compute or something. They all be
yeah,
they're
I mean,
specialized. They might be specialized, or they might just be. If one computer is enough to do all those things, then they will use one computer. But if it runs out of capacity or needs to be specialized, they will put
that's one of the thing actually. The next thing is, for example, here 10 employees there, right? So the 10 employees have their own duties, keeping Excel files, keeping Word files, other related files related to the company. So he will log in the machine and do the thing, and after leaving the office, they will push the daily files or daily things in this file server. So after we leave the office, we didn't go to this machine and access the file. We can easily access from the file server that who is done this, like that. We can segregate all the things. Yeah. That's one of another thing we keeping this type of files in file server, and we can store all the data in the file server. This is we can use more size address or like that in this machine. Got it?
Yeah.
So yeah, you can consider this is a local area network. And when coming to cloud, okay, this is on-premise. When we need to switch to cloud or in cloud, we need to do this. I mean, exactly same things in cloud actually. Okay, I mean, consider this is one network. Okay, this is the network 1, and this is a network 2, and this is a network 3. A network in the sense of we segregate the network actually. Okay, this is subnet. The segregation means the name is subnet. You heard about subnet, right? Subnet 1.
Yes, the part of the IP address is reserved, right? So it's the numbers, you're getting a multiple of numbers, right? So if you save some part of the bits, you could define another address space and make a subnet.
Yes.
It's like they make slices of the pizza, right? If you make slices of the pizza, and you can share the pizza with people.
Basically, subnet is it's a ranges of IP actually. For example, yes. I have 100 candies. Okay, so I will divide the 100 candy into 4. So 25 I allocated to someone, 25 another someone, like that.
Yes.
That yeah. I mean,
every machine will get its IP address, and between the machines IP address and MAC address and encryption, it gets identified, right? That
yes,
who is talking.
Yes. So this is subnet 1. Consider the first block is subnet 1. Okay.
Yeah.
I mean this is subnet 1, and this is 2, and this is 3. So we again segregate the network actually. That is here there is 3 subnet. Okay.
Yeah.
Yeah. So just keep in mind, okay, when we are coming to cloud, we need to dig more into subnet and all the things.
Right. I think your sound has gotten turned off. Maybe mute button was hit by accident or something.
Now it's clear, right?
Yeah, I can hear you now. I can hear you.
Okay, fine.
Maybe you're not saying anything for a bit.
I think so. Yeah. So yeah. Then we are going one scenario. Okay. So one more scenario like this is on premise. This is a rack actually. Consider this is a rack, and we need to deploy an application. Deploy a application, on-premise application. Okay, this is a scenario in on-premise. Deploy a app, web app. Okay, consider this is a web app for company application or anything like that. Okay. This is a company abc.com. Okay, so right. The abc.com have one application. I mean a web application. So we need to expose the application to the public or the customer. So who can access abc.com, they will access our application. I mean, our company details, what are our mission, vision, all the things we have specified in the application, right? So they will need to access. So what will we do as a IT engineer? We are the hired IT engineer company. Okay, this is a new form of company. So first we need to buy server, right? I'm audible, right?
Yes. Yes. Yes.
Yeah. So this is the server.
You install your web app there.
Yes, this is a server. Okay. So this is a server. Okay, server, different types of server, like blade server. This is a blade server, and some tower server like that. Okay, this is some tower server. Different models there. Okay, I mean the physical
Yeah.
model.
Yes.
And okay, so my
Depends
question
on
is,
how the customer wants to use it. They can make different models.
yes,
They can have it if they want to put it into the rack. Then they use the
yeah,
rack.
most probably in data center keeping racks actually, so it's less space, so we can keep more things there. We didn't go with the maybe these types of tower or anything like that. So my question is, what is a server and what is a client machine? What are the difference between the client and server machine? Any idea?
Client will ask the server for, send a request, HTTPS request to the server, and the server will respond on that request. So there is code on the server that knows how to respond, and there's code on the client machine that knows how to ask for stuff. Now, machines can be, a machine could be a client and a server both, but generally the way it is set up is that server is designed to listen to requests and respond to them. Get, put, pull, and I think there are some 4 Java words, right? Get, request, post, based on whether it wants to see something, right?
But these are all the things done by the local machine also. Both machines can do these things. Yeah.
Right.
I mean the physics.
Client is what wants information, server has information and gives it, right? Server serves the information, client asks for the information. That's a simple definition, right?
Yeah, but I mean, did you see server?
Did I see a server?
Yeah.
I mean, I've seen the server room racks, how they are kept and how stuff is installed on them.
Okay, then I will give you a small anatomy. Okay, this is server. Okay, and this is the machine. I mean, local machine or the personal machine we are working like similar. I mean, in our personal machine, right? There's a CPU monitor or like that. Okay, this is a normal machine, like local machine.
Yeah,
like in our home there is a machine, right? Same way, this is a local machine, and this
can
is
I ask
server.
you one question?
Yeah.
So right now you and me are talking on this Zoom call. So your machine and my machine are both clients, and the server is sitting in the Zoom's data center, right? The server
Right. Because we connected through the Zoom application, so we need to connect to the Zoom server.
Yeah. So it's kind of fast. Like I feel like I'm talking to you live, but it's going to some server and then
go through the server. Right. Yeah.
The same time.
We are hitting the server through the server actually.
Yeah. It's kind of amazing how fast it is. It used to be very slow. Like initially the video would play, you would see the circles moving and the video would not play. And now there's entire movies moving back and forth.
Yeah. So the major difference here is nothing simple. Okay, I will explain. First, we need to explore the local machine. Okay, so when we are buying a machine, okay, I mean some intention there. Okay, like as a kid, I need to play big size games or like that. So we have some specification or the configuration, right? So as per the configuration, we choose the machine. For example, I need a PC, and the PC at least have 4 GB RAM and 2 GB graphics card, like that. So this is coming to the local machine. I'm going with the 2 GB RAM, okay? So I can expand the RAM as per my need. I think it's expanding to 8 or 6, like that. So basically 2 GB RAM there. Then hard disk is 1 TB. Consider this is a 1 TB asset. And the main thing is the processing power. Okay. The processing power may be dual core, or starting on the Pentium, right? Pentium, dual core, then i3, i5. There is, as per our need, we need to choose the core CPU power. Okay. So consider this is dual core. Okay. Dual core. There is 2 core there for processing the request and all the things in CPU. So this is 1 TB hard disk, and this is the 2 GB RAM.
Right.
These are the main components inside the CPU actually. So this is a requirement for, this is the scenario when coming to local. So similar way coming to server, this will change actually. Coming to the RAM, here the RAM may be starting with, as per our need, we need to customize the thing, but starting with the 16 GB or 32 GB RAM, like that. Okay. Right. And coming to the storage, okay, there is a lot of options in coming. That's one of the thing we can keep. I think four of hard disk in server actually. There is a 4 rack inside the server for plug in the hard disk actually. So here there is 1 TB or 2 TB, like that. Okay. 1 TB, 1 TB into 4, like that, into 4.
Server is generally a more powerful machine. It has more hardware.
Right.
And the cloud is basically made up of a lot of Linux servers.
Yes.
It's what the cloud is made up of.
Yeah. So coming to the processing power, here is a lot of core, like 16 core or 8 core, like that. Okay. 8 core. So this server can process a lot of services, right? At a same time, the process, this server machine can process a lot of request and the process all the things. That's why, that's why we call a server is a powerful machine when comparing to our personal machine. Got it? And for server, there is a server OS there.
Yes.
For example, for local machine, this is coming to the Windows. Okay. For using Windows, we use client OS. Windows 7, Windows 8, Windows 10, Windows, the latest version, right? 11. These are the client OS actually. So that's why that's the OS we are using for our local machine.
The Windows server would be the server system.
Yeah. Windows, coming to server machines, there is server operating system. Got it? Right. Yeah. For each video,
the brilliant part about Linux is that whether it's a server or a local machine or a little embedded device, they're all still running the same operating system. That's why the simplicity of Linux is attractive to some people.
Yes. For Linux, there is Linux operating, Linux server OS there. Most probably we are using Linux, Red Hat operating system, Ubuntu. So many operating systems there for coming to the Linux environment. When we are starting, we are mostly work with the Linux actually. We didn't install Windows in lab actually. We are mostly concentrated on Linux.
Yeah.
So here,
some people say that Windows on the inside is secretly like a Unix machine. I heard that rumor. I don't know if that's true.
You mean inside a Linux machine? We
Oh,
keep
like
a
some
Windows.
people say that Windows is a closed source operating system, but I've heard some people say that inside it is basically a Unix machine. That they don't. It's
I
it's a
don't know
rumor.
that.
I think. It's a
There
rumor.
maybe there is some kernel, but I think it's a rumor actually.
Yeah, yeah.
Yeah.
Who knows? Because you don't know what the source code is, so you don't know. Really.
Yeah. So yeah. So coming to server have their own OS. Okay, they will release the server OS there. Most common servers are Windows 8 R2. This is that period in 2018. So sorry, 8, 9, 10. They release a server OS called Windows Server 2008. Then after 11, the next release there, Windows 12 R2. Then Windows 16 R2 there, and Windows 2020 is, I mean, the recent one.
Yeah.
I worked with the Windows 16 actually R2. That's a 16, 17, 18 period. That's OS or operating system for the server. So this is a same working principle in coming to server and the local machine. Okay, so this is a high level overview. I'm just add this thing because a lot of the people in previous section doesn't know idea about what is server and what is. But for you, I think you are familiar with these things. Okay, so our requirement is deploy a web application. So what we'll do in our office, we need to buy one server. This is a bare metal server. So bare metal means nothing, just hardware. Okay.
Yeah.
Just hardware, and this cost may be I mean, as per the requirement, we can choose. It's starting from 70K or like that, or 80K, and it's go up, right? 1 lakh, 2 lakh, 3 lakh, as per our need. As per the configuration, the price may be high, right?
Oh, yeah.
2 lakh, 3 lakh. Okay. So the next thing is we need to install the operating system, right? So we install like any Ubuntu. Okay. This is coming to Linux. Okay. Ubuntu. Or if you are keeping this machine as Windows flavor, then we can choose the Windows operating system like 2016 or 8, 12. I mean, any operating system, server operating system. Then we need to deploy this application. So we have some prerequisite. I mean, before deploying the application. I mean, we need to serve this application to the requester, right? We need to serve the application. Who will serve the application?
Server.
This is a server, okay, but this server can't directly serve this web applications actually. For serving web application, I mean,
there is a web server that will get the first the DNS server will parse the request to go to the right web server. Web server there'll be a firewall outside the web server, and then the web server will find a server inside the internet company that has the right information.
You're right. We need to configure the web server.
Yeah.
Web server. Don't come, mingle with this server. Okay, this is a server, and another thing is a web server. Common web servers are Apache. Heard about Apache, right?
Yes.
Apache.
That's what they call the LAMP acronym. Linux,
yes.
Apache,
Yes.
MySQL, and PHP. Right? These are all complete open source, free from any corporate control.
Yep. And another one is, give me a second. I need to plug it the power actually.
Yes, sure. I think in the age of the internet, a real person talking to you is very priceless. The time you are giving talking to me as a person, one person to another person, is priceless. very valuable.
Yeah. Hello.
Oh, yeah, I'm there.
Yeah. So, yep, we need to configure a web server before deploying the application. Okay. So we can choose the common one is Apache. So we need to install Apache. I mean, first we configure the bare metal server. I mean, using operating system, that is Windows operating system or Ubuntu or Red Hat, anything we can install as per our need. The second
Maybe
thing
another
is
machine that's a web server machine.
the next. Sorry.
There'll be a separate machine that's a web server.
No. Web server is a name actually.
Okay.
Yeah.
It can be installed on the same machine.
Yes. I mean, Apache is a web server. Apache is a web server. Tomcat is a web server. Okay. This is a service actually. So we using
Depends
any
on
service.
how much the demand is. If it's like a big application, and then there'll be multiple computers that do that job, right? Web server will be a different machine.
Yeah, that will
If it's a small application, then one computer can do all those things.
Yeah, I will explain that thing. I'm going to that's the scenario. Yeah. So yeah. So I'm choosing the Apache. Okay.
Yeah.
So I install Apache inside this machine. Then after successful installing the Apache, we have a path. I mean, to keep our application code. So I put the application code into the corresponding path. Then yeah, fine, it's fine. I mean, then we can resolve the using IP or resolving DNS with the IP or anything. Then the users can access the application through the IP or the domain name. Okay, this is a scenario actually. So coming to real world scenario, we need to keep at least 2 machines for deploying these types of application. I mean, if the application is crucial for this company, then we need to make sure, okay, this application is available for all the time. So what we will do for deploying these types of application, at least we need to keep 2 server. I mean, this identical server, okay? We need to buy 2 machines here. So the cost may be same like 70 again. Consider this is a 80K mission, okay, 80,000. And again, we need one more 80. And what we'll do, this is server, another server 2, and install the operating system, then do the, I mean, install configuring the Apache, then keep the same application going to this mission, and we need to connect with this mission, okay. Now these 2 missions have a connection. And in front of this mission, we need to configure a load balancer. Okay. This is a connection actually. First, the user is accessing abc.com. Okay, consider when the remote user accessing the application, first the request hits to the load balancer, and the load balancer will route the traffic. I mean, route this user's request to the corresponding machine. There is an algorithm there. Okay, I mean, different algorithm there. Coming to AWS load balancer, the default algorithm is round robin. Round robin. Round robin means first the load balancer will send the first request to this machine. At the same time, another person accessing the application, then it's sent to this machine. Like that. Again, another request come, then it's route to the first machine and second machine.
This is like a round, like it's a circle, it keeps going.
Yeah, it's a round setup. Like this is 1, this is 2.
There's like
again
5 machines, it will rotate
between
5.
Yes. So this is
like cards to play cards, you know.
So this is the scenario. Okay, how we set up the applications and the machines in the on-premise. So my question is, consider this application. Okay, this ABC application is a e-commerce application. Okay, I mean, this is the application where the users are surfing and they will buy our products. Okay, I mean, this is a company, abc.company. This is a e-commerce company, and we list out all the products in this website. Okay, so we have daily 500 to 500 to 1K hit daily. I mean, this much users are accessing our application daily. Okay, in between. Okay, and these two machines can, manage this much of user, no problem. Okay, after some periods, due to the popularity or anything, we got so many users. The request count is again rise like 5K to 10K. This much of users are accessing our application nowadays. Okay, this is a previous one, and nowadays this is a hitting count. So this much traffic can't handle with these using these two machines, right? Because the machines have some capability at the same time, right? You heard about the DOS attack and some attacks like DDoS attacks.
Yeah, distributed denial of service. If
Yeah,
attack sends too many requests,
sending HTTP request to the victim machine, right? So the machine will hang. So the machine will
make the web service crash, basically.
Yeah. So the similar way here, we have only two machines with the basic configuration or minimal configuration. So these two machines can't handle this much traffic. So basically, what will you do? As an IT person, nothing. We need to buy. We need to talk to the management, and we need to buy one more machine and clone up the. Connect with the machine, right?
Yes.
This is the only scenario to handle this much traffic. So we will again going to, go to buy one machine and do the odd configuration like OS, then the server configuration, then copying the file.
Hopefully, your company is thriving because it's increasing in users.
Yes.
So you can afford.
Yes. So now we have 3 server. Now we have 3 server, and this much traffic we can easily handle, right? Okay.
Yes.
So the next time again, the hitting count is rising, like 20K or 20K to 50K. That much user we have. What we'll do? Nothing. We need to add more servers like this.
30 more servers.
Yeah.
10 times the more servers.
Yeah. As per the count request, we need to scale up the thing, right? Because this is impacting our business. So we need to do the things actually. So same way, the same scenario we need to copy. And again, we need to give the money to for buying this thing, 80K again gone. So like this is a scenario actually, okay? But after some time, this is going down. We go back to the 5K and the 10K, okay?
And we're stuck with all.
Yeah. So nowadays we have only 5K to 10K in between this much user access only. So coming to our IT infra, this is useless, right? These resources are not utilization actually. Because for handling this much traffic, we only need 2 or 3 servers enough. And here we buy one more server or 2, or like as per the scenario, we need to add up the machine, right? So sometimes these added machines are useless, or the resource is not utilizing. Yeah. So the cost is one of the problem. And then the manpower, the configuration team there, the IT persons, all the things are there, right? So this is the one of the drawback in on-premise. So I am doing the same thing in cloud, okay? So coming to cloud computing, okay? What will you do?
Requirements for the world.
Yeah. So this is considered, this is the AWS, okay? So we need to start a business. So we have an application. So what we do? Log into the cloud computing, log into the AWS and spin up the machine. Okay. Here, set up the machine. It will take a lot of time. We need to purchase the machine. It will take time. Then take the machine and put it in the server room rack, and plugging, screwing. Then there is a wiring connection, right? The network wiring, power wiring. Then configuring the machine or installing operating system. So it will take a lot of time, right? In coming to the virtual, the physical world, non-premise. So coming to cloud, we can within seconds we can deploy a mission. This mission, same way in AWS, within seconds, I mean 50 or 40 seconds for configuring a similar type server in AWS or Azure or GCP. That is one of the plus point in cloud computing. Got it?
Yes, it's like, say, we buy the electricity we need from the utility company, and we don't worry about setting up more and more generators because you'd have to buy so
Yes.
many generators,
Yes,
right?
yes, right.
So, but if someday we don't use that much electricity, we don't pay that much bill.
You mean pay as you go, right?
Yeah, yeah.
Yeah,
But electricity is a little bit simpler than compute. Compute has more choices and configurations, but the concept is still the same. Buy it like it's a utility. Buy it
right.
as you need it, right?
Yes. Okay. So, for deploying application, what we'll do, we need to spin up two mission and configure the same thing. Basically, we call these two missions are an identical mission because the same things inside the both machine, right? Even the application code, server, OS, the web
So you
server.
can scale your EC2 instances to as many as you need, right?
That I'm
If you
going to, yeah. This is called a manual scaling. You figure it out. I mean, coming to the on-premise, we have these two missions, right?
Right.
As per the demand, we need to scale up the machine. What we'll do, we buy one more machine, again we one more machine, right? This is called manual scaling. Manual scaling. Okay. So coming to the same scenario, coming to cloud, okay, we can set up the scaling scenario inside the AWS provider or any provider. Okay. I mean, we can set up the things like, for example, the CPU utilization or the memory utilization is above 80% or 70%, spin up one more machine. That's the scenario. So we already set up all the things in the setup configuration. So the utilization above, what will do? The provider will automatically spin up one more machine. We didn't go through and do the things. This is purely done by the AWS. I mean, they will configure one more machine and what are the things inside the machine? I mean, in server 1 and 2, that will automatically in the third machine. Again, this will be, I mean, these three missions will utilize more, what are things we've specified in the configuration, okay? I mean, the CPU utilization, again, below, I mean, above the 80% or 70%, again, they will scale up one more mission like that. Again, it will, I mean, do the things, okay? We set up the mission count actually. I mean, for example, it goes until 7 mission or 8 mission, they will only go, I mean, spin up mission to 7 or 8 like that. Okay, then what we'll do actually here is the count will go down sometimes, right? I mean, the specified count is down. What we'll do, automatically they will remove the machine and back to the state. I mean, the desired state. This is called a desired state. Desired state. Our desired state is 2. So they will mention, they will maintain the desired state and spin up as per our configuration. I mean, we need to configure the thing in the scaling configuration. In scaling configuration, we need to set up the things
they have
like
different options. They say, are you committed to using this much? Then you get a lower rate. If you are going to randomly just ask for stuff, it costs them more money, right? So they'll
yes. And we need to pay for this spinning mission actually. And we go back to the desired state actually. Okay. So this is called auto scaling.
auto scaling.
Auto scaling. Okay. And one more thing we need to learn from here is
The A and S keys are close on the keyboard.
scaling. Again, yeah, leave it. Okay. Yeah. So using auto scaling, we can say like there is high availability also, because our application is always high availability. I mean, keep high availability. Right.
Right.
Yeah. So this is the one of the plus point why the corporates are nowadays moving to cloud. Got it. Here we
economy of scale, right? The big companies like Microsoft or Amazon and Google, they have a lot of servers, so they can lease out their compute power compared to you having to buy all of it.
Yes, yes. So you will get the idea, right?
Yeah, yeah.
Okay. So then high availability. This is scaling. Okay, different two types of scaling there. So I will explain the scaling. Commonly two types scaling. Okay, one is vertical and horizontal. These are the two types scaling. One is vertical scaling and one is
you need
horizontal.
more of the same that is vertical, and horizontal means you need different types of things, right?
Yeah.
10 machines, they're all the same. That's vertical scaling. You need 5 different machines. That's like horizontal scaling.
No. Actually, this is purely example of horizontal scaling.
Okay.
Horizontal scaling is nothing. This is a PC. Consider this is a machine. Okay, server machine. So we need to scale the machine. Okay. So there is two way we can scale. Scale the entire machine and scale the resource count or resource. Resource count actually. So coming to vertical scaling, we have one server. So we need to add one more server. This is pure example of horizontal scaling.
Okay.
Here we do the same thing. I mean,
more of the same is horizontal scaling.
Yeah. So coming to vertical scaling, okay, we have one machine. This machine have 2 GB RAM, 4 core CPU, 1 TB hard disk. So coming to vertical scaling, we didn't add more machine. We just add the resource. So when adding the resource, this 2 will be 4. Or we can choose as per our need. 1 TB is coming to 2 TB like that. 4 core is going to 8 core. This is vertical scaling. And coming to vertical scaling, one of the drawback is we need to shut down this machine and scale the machine. From horizontal, we didn't shut down the machine or anything. Automatically, it's copy the machine and create one more machine like that. Copy the configuration and create one more machine. So coming to production environment, we are not configuring this vertical because we need to, turn off the machine. So it will impact the business.
Right.
Got it?
Yeah.
So two type scaling there. One is vertical and one is horizontal. Horizontal is purely copying the machine's configuration and create one more machine like an identical machine. And the vertical is adding the existing machine resources. I mean the processing resources, storage, all things.
Vertical scaling is a qualitative change to the actual computer that you're using. And horizontal is more and more computers are the same.
The pure example is, for example, we have a personal computer and we have 2 GB RAM. So we need, sometimes the machine will hang, right? So we need to, what we'll do? We buy one more RAM, or just upgrade the 2 GB to 4 GB RAM, right? So we buy one 4 GB RAM and open the CPU, then plug it the RAM, right?
Right.
Yeah, that is purely vertical scaling. At the when the time of, I mean, removing the RAM and all things, we need to shut down the machine, right?
Yeah, yeah.
Yeah, same thing. You heard about these two things?
Yes.
Any
Region
idea?
would be, let's say, uh, a geographical region, and
Hmm.
each region has multiple availability zones inside it, so
Hmm.
that if something happens in that region,
Hmm.
there is still they are they could use another data center. So they, let's say a big city like Mumbai, they'll build 4 data centers in there, and they'll
Hmm.
all be 10 miles apart. If some big catastrophic event happens in Mumbai, it's okay. One of the availability zone will have, and you have different product options where you could have your data backed in different availability zones, or it's all in not backed up in different availability zones, but their availability zones are inside the region.
Hmm. Hmm.
And then the
Region.
region is geographical all over the world. So if you have data that is in the European Union and legally you have to keep it inside the European Union, you choose the EU Union, or US Eastern, US Western, US Central. They have, Amazon has infrastructure all over the world like that.
Okay, fine, fine. You are right. You are right. Actually, a region is a collection of available zone. That is called a region in simple term. Okay, what is region means? It's a collection of available zone. And what is available zone means? Availability zone actually it's a kind of data center, and inside the data center the resources are there. I mean the servers.
It might be one or a few data centers, right? It may not just be one. It might be 3 data centers
Yeah,
availability.
that at least there is
Anything. It could be
two
just one, at least one, but more than maybe.
yeah.
But at least one data center is availability zone.
Yes, yes, yes. So coming to, this is considered a region. Okay, this is a region 1, region 2, region 3, region 4, region 5. This is a globe. Okay, this is the globe.
Yeah, world.
And consider this is I mean US, this is Canada, and this is Asia specific regions like yeah, Asian, and like they keep some regions. I mean they segregate the globe locations and they keep uh, each regions. Okay,
Yeah.
so coming to the region 1, there is different availability zone there. This is availability zone 1 and this is availability zone 2. Availability zone 1 and 2. So inside the availability zone means the pure data center,
Yeah.
or the server farm there. Okay, I mean this is inside the data center means there is a huge building there, and inside the building there is lot of machines. Okay, so the networking components there, the IT engineers are there to manage the infrastructure. I mean the yeah, data center, all the things. Got it. And
Yeah.
similar way, region 2 is far different from, I mean, far away from the available zone 1. Okay, for example, this is in Chennai and this is in Mumbai, like that. Means available zone in Chennai and Mumbai. I mean, any flood happen in Chennai, okay, our available zone 1 is collapsed or it's facing some issues, okay, or it's any problem with the available zone 1. Our data are in availability zone, that is in Mumbai.
Availability zones at least 10 miles apart from each other. So
Yes,
hopefully a
yes, yes,
calamity doesn't spread more than 10
yes,
miles.
yes. That's why they keep the available zone and they will put the each available zone at least far from the 1 and 2 or like that. That
Yeah.
is called high availability, one of the feature of cloud, because
Yeah.
our resources are high availability, high available all the time. Got it.
Yes.
And nowadays they are planning to add more regions. Okay, I mean when the provider will grow up, they will add more region and more available zone as well, because some regions have a lot of available zone, like 6 or 7 available zone. Some regions have less than 6 or 7, like 2, 3, like that. Coming to India, I think there is 2 available zone there. I think one is Chennai and Mumbai for AWS. For Azure, there is more than that. I don't know actually.
Yeah, Bill Gates came to India and Chandrababu Naidu came to receive him at the airport. So he sent infrastructure in like Hyderabad area.
Yeah, I think they will add more available zone there. Yeah.
Yeah, Chandrababu Naidu was a very smart CM. He went to get the Maharashtra CM was not that smart to go receive Bill Gates. That's the story I heard. This is an old story.
Okay. Yeah. Yep. This is a high level overview. Now you know actually the thing, right? I mean the region and so on, all the things. Just to clarify the things. That's all. Yeah. So yeah, this is called availability zone and the region. Any doubt?
In the computer programming world, every word is programmed to be some meaning. So the context of English language becomes a little bit different when you describe technology, because technology is, the word is defined in a more precise way, but it in a colloquial language you could still understand what somebody else is saying without that precision, right?
Yes, yes. So regarding available zone and region, you have any clarification or any doubt?
No, I'm
nothing,
good.
right? Yeah. Yesterday's section we talk about the AWS, right? So may I know you taken, right? I mean the AWS account.
Yeah, I have put in my email. I just have to add a credit card or some debit card or something.
Could you share
I
the
just have to be
screen?
careful about how I'm using it, so I don't get some crazy bill.
Could you share the screen, and if you possible, then we can go through that.
Or the screen? Okay, yeah. Let me get my other computer online.
Okay.
Need a few minutes.
Okay. Yeah.
You can go ahead teaching if you want to.
Yeah, I think this things is done actually. So
Recording in progress.
You see two of me now.
sorry.
I close Zoom on the other machine so you don't get the feedback. Hello?
Yeah. Hello.
Yeah, I close Zoom on the other machine so you don't get the feedback. I have to go in.
No, you are in, right? I mean, I accept the request.
Yeah, so I using my Linux, my Ubuntu machine, but
Okay.
because I had my Mac and my Ubuntu both on same time, it was creating like a feedback of sound.
Okay. I think any mission you need to mute the mic. I think that will be.
Yeah, I tried muting the mic there, but it didn't work. It still gave feedback somehow.
Yeah.
You
So
want me to
yeah,
share the screen? Do you see my screen?
yes.
It's basically just saying to me I have to
Sign in.
yeah, no, I have to add, it's basically stuck on the screen. So every time I go in, I say put in the money first information before I can go do other things. So
Just provide the debit card details here.
yeah. I'll have to take I don't have the card picked yet and put there, but there is a way I was navigating to other screens for a while
Sure.
and able to see some stuff, but yeah, so should I stop sharing and then when I put this in, share with you at a later time and
Yeah, fine.
yeah, never don't keep you longer than you need. Were you gonna give me some tips on how I can be careful with the not getting a bill?
You just provide your debit card, okay?
Okay.
Put your debit card. At the time of adding the debit card, they will charge some. I mean,
$1.
$1. Yeah. Coming to India,
They
there is
basically want to
two.
identify you. So they want to know your address and your, name, phone number, and a credit card so that they probably get a lot of attackers on it too, right? So they want to keep it a little safer. So they part of the
That's
using the
that
credit
that
card.
that that's why I mean, using the debit card. Okay, so at the time of they will charge the $1, right? So you will prompt to the corresponding bank website. So that is encrypted actually. Don't worry about that. So they will charge the amount and you can back. I mean, then again reload
Yeah,
your AWS account.
yeah.
If we provide the credit card, I think I don't know, they will recurring the charges, I think. But
Well,
coming
what
to
I
AWS,
learned, one thing I learned is that if a identity thief takes your debit card information and steals the money from your account, then you are responsible for losing that money until they
yes.
find the thief and credit the money back to the bank account. But if you use a credit card and identity thief steals your credit card information, then the bank doesn't hold you responsible for that because it was a credit anyways and you didn't use it. So
Yes.
the credit card company carries that liability in US. I don't know, India might have different law, but in US, it's safer to use a credit card than a debit card.
Got it.
I think there's one more participant, Andrew, on the call.
Andrew is our previous batch guy. Yes. Hi, Andrew. You there, right?
Hi, Andrew. I'm in a new.
Yes, yeah, I'm here.
What's up?
Yes, everything is fine. I'm taking a vacation to Africa, so
You are in Africa right now.
No. Next week I'm leaving.
Okay.
Oh, have a good trip.
Yeah. So I'll come back and then I continue the class with you. Thank you so much.
Yeah.
For your knowledge.
Yep. Andrew, you completed all the labs, right? I mean, our labs.
Yes,
Okay. Did you face
I
any
completed.
difficult, I mean, go through the labs?
The lab, no, if the only thing is when I go back to the video,
Okay. Then
the
sort
only
it out,
place
right?
that I visit, yeah, I sorted out when I go back to the video.
Mhm.
So I figured it out when we are in Kubernetes, but I'm able to do it. Yeah.
Okay.
But I think deployment from Jenkins,
Hmm.
Docker, deploying with Docker.
Hmm.
I think that's the only place I have to go back again.
So you are facing some issues while, I mean, deploying through Jenkins to Docker, right?
Yes, Docker. I think Docker is the last. Yeah, that is the only place that I'm facing issue. You remember what I was facing that issue when I tried to, for example, I think it was because of
Permission.
my permission for AWS or something like that.
You just
Yes.
send me the shot, okay? I mean, when you do
Yeah.
the same lab again, you face any issue,
Yeah.
then I mean, send it to me. We can check it out.
Yes. So far, that is what I'm facing. Using Jenkins for deployment to Docker.
There is
That is what.
there is two things there. One is any issues in the pipeline script or in Docker
Yeah.
permission issues. Or else
Okay.
sometimes it's face some credential issues that we provide in the Jenkins.
Yeah, credential. Okay.
Okay. Yeah, then yeah, Amol, you take the account, okay? I mean next section
Yes.
we are going to I mean coming
Start
Friday,
working on the.
Monday. Sorry.
Okay. Yeah. I should sign up. I should just put in my financial information there so that I can get
Okay.
get it moving forward.
Okay, fine. I mean, it will take some time. I mean, after registering your account, I mean, we will get a full account. It will take some time. I mean, 7 hours or 6
see.
hours. After
I
6
see.
hours or 7 hours, we can, I mean, utilize the AWS account.
Okay. I will do that.
Yeah, just go through that. Okay.
Okay. Yeah.
So we can wind up, right? First section.
Sure. Thank you so much for your time. Have a good day at work.
Yeah.
Or today's Saturday for you. You're off.
Yes.
So enjoy the free day.
Yeah. Have a weekend for both of you.
Same to you.
Yeah.
Thanks.
Okay, then bye. Bye both of
Bye.
Andrew.
Nice meeting you, Andrew.
Yeah.
Bye.
Yes.
Yeah. Bye.
Okay.
Thanks.